Hi, myself as Prakash, Assistant Professor, Department of Mechanical Engineering. So today we'll start about the ANSYS workbench. So initially we'll see about what is the study of analysis and what is the applications and what are the benefits by using the analyzing software. Next, we'll see about introduction of ANSYS workbench. I'm going to open the ANSYS workbench software and I'll explain what are the tools it's available step by step. What are the things we're going to be see in our ANSYS workbench. So first, that how the analyze will be coming means normally in our engineering we are studying about subjects. First, initially in the first semester you are studying about engineering mechanics subject. Second semester, I hope engineering mechanics. It's a basic subject for civil and mechanical we are studying. Next, from our mechanical engineering, we are studying some the category of manufacturing field. So manufacturing technology 1, manufacturing technology 2. Next, from that we are study about computer integrated manufacturing, computer aided design. Like that subject we are studying. Next, advanced unconventional machining process. So different types of machines we are studying, right? So in all those, we are studying about lot of things about your mechanicals. So normally we are study about some small products. Some from small products, example manufacturing of pencil to biggest products, everything. So for every project, we're going to need some analyzing report, right? So example, if you go for the civil means it's a beam, structural beam, cantilever beam, like that. So subject you are studied strength of material subject. So in the strength of material subject, cantilever beam, simply supported beam with the point load, uniform distributed load. So all this area where we going to use means it's the application of different field. So in our road, bridges, next automobile industry, biomedical industry, everywhere we have lot of things. We're going to be go for the analyzing one. So for that purpose, we have that one subject. So design is one of the subject we having. After making the design, whether the design is correct or not, whether the design is accurate, how much life of the design, everything we're going to be calculate means with help of the some analyzing software we use. So the basic software we have that analyzing software is the ANSYS software we going to be use, right? So we have that 7th semester we're going to study about a finite element method subject. It's a finite element method, or we can say finite element analysis, FEA or FEM. So here basically what we're going to means normally we're going to draw any one structure. After making the structure, we're going to apply some boundary conditions. After applying the boundary conditions, what is the result? That only we're going to use in FEA. Why FEA actually? So FEA means normally finite element analysis. What is mean by the finite element means? So if you have any one structure, means so in this structure, if I'm asking simply, I'm asking one question. So we have the structure of circle. Okay, we have the structure of circle. It's not a perfect circle, somewhat like that on circle I'm having. Okay, in that circle, I'm going to keep lot of points. Means I'm asking how many point is possible to keep in that circle. So what will happen? It's a infinite, correct or not? We can't able to say it's exactly how many points we having. That means it's a big circle means we can make lot of points. So we can't able to find how many points is there. So in FEA, what I'm going to means that infinite points I'm going to bring into finite. I'm going to bring into finite. How I'm going to bring into finite means with help of elements. With help of elements. So with help of the element only, I'm going to finalize the infinite into finite shapes. I'm going to bring infinite into finite shapes. Then I'm going to apply the load. Then I'm going to find the result for the particular area. If I found the particular area means that particular area I can find every area. Example, now I'm going to say about your strength of material subject. So in strength of material subject, I'm going to asking a simply supported beam is there. In the simply supported beam, exactly in the center, I'm going to apply the point load. So what will happen? You want to find that how much the deformation take place means you have the formula. Example, stress equal to load by area, strain change in length by original length, next how much load we are applying, so how much deformation, everything we can have the formula. But what will happen means particularly the particular place only how much deformation will take place, that only we can find. But by using this ANSYS software, we can find from the entire object, we can find how much stress or how much strain or how much deformation will take place for the entire object. So that only we're going to see, right? Now we'll see the applications. What is the application we are using? Normally, if you see solving means, while I'm saying mathematical models, so in the strength of material means we are using the mathematical formula, either integration or differentiation. We're going to find the solution for the particular areas. So in our engineering problem, we can't able to find for all the objects. So we have this software. So by using this software, we can use that means automobile industries, everywhere we can use this one. So what is the major application of this finite element means, such as the industry like automotive, aerospace industry, defense industries, consumer products, small product also we can able to find that solution, and industrial equipments, transportations, for everything we can possible to find this solution, right? Not only that engineering area, nowadays see that the application have been extended to material science also, material science, biomedical engineering, geophysics, and many other engineering fields. Nowadays we are using this ANSYS software, right? So what is the procedure of ANSYS? Normally in the seventh semester you are studying finite element means, we have 10 steps, so the 10 steps will be divided into three categories, that is pre-processing, analyzing, and post-processing. Here also in ANSYS Workbench software also we are using the same concept only, sir. Three process only. The first one is pre-processing. So in ANSYS Workbench, what is the pre-processing means, initially we want to build the model. So build the model means it's a geometry. We want to create the geometry. Before creating the geometry, if you want to assign the material also, that also you can assign the material also. It's come under the pre-processing. So what is the analyzing means, you want to open the model window. In the model window, we want to apply load and applying the boundary conditions. So that is the analyzing area, sir. Next, what is the post processing means, we're going to review the results, right? So this is your general procedure of ANSYS software. Now I'll explain you what is that, how the ANSYS Workbench software is available, and what is the how the concept we are using, right? Just a minute, I'll open that ANSYS. See there, ANSYS Workbench. I'll open the ANSYS Workbench. Your system is somewhat slow. Please wait. It's opening. Yeah. So this is your ANSYS Workbench. So if you see the open means, we have the ANSYS model windows. So left side we have the analyzing systems. So here we have seen the different types of applications now. So for those applications, we can check fluid flow analysis, harmonic analysis, IC engine analysis, buckling analysis, model analysis, static structural analysis, steady state thermal analysis, transient analysis, thermal transient analysis. All those things we can able to find out. So this is the geometry windows. So initially, some example, I'm going to start with the static structural. See that, click and you can drag here for opening the static structural. See that you can do like this. Otherwise, you can double click also. See that if I make double click means automatically the next screen will be open. So you can Sorry, just a minute more. Okay, right. So if you see means see there, you can open here also. So this diagram, other again, I want to open here means see there. If I need to draw the linear buckling means see there, click and drag here. So again, I want to do the model analysis, but the same geometry I'm going to use means see there. From the model analysis, I'm going to click this geometry and see there. This geometry means what will happen? See there. The engineering data and geometry I'm going to use from the static structural, so I can make a model analysis. Like this, different properties we can do from your model analysis. So this is the steps, right? So next one. So it will be down means go to view, reset workspace. Next to reset work windows, you can possible to open, right? This one. Next, I'm going to, once you open like this, different, you can draw static structural, linear buckling, or model analysis, or harmonic analysis. See the harmonic response, you can draw that harmonic response, IC engines, like that we have everything. So initially this is the first stage. We'll go for the pre-processing means, first of all you want to check your engineering data. See the engineering data means here only we have the materials. So you can make double click, otherwise you can right click and edit option, any one option. So if I make double click means see that initially the materials box will be opening here. So here that library we having in that library, see that normally the default material is the static structural steel will be there. If you want to go for some other data means see that here engineering data source is there, you can click means see that here we have the general materials and general non-linear materials we having. So if I click the general material means see that what are the general materials, you know what are the types of general materials having, uh, aluminum, concrete, copper alloy, grey cast iron, magnesium, polythene, silicon, stainless steel, structured, and titanium alloy. These are the some general materials is available. You can go for the general non-linear material also. See that if I click means see that aluminum alloy, nickel, concrete, nickel, next copper alloy, gasket, magnesium alloy, stainless steel, like the titanium, some other grade it's available, right? I no need this type of material. I want to create new material also. You can create. See that from that engineering data. See that from that engineering data here. Click here to add new material. You want to click here. Next, you can create some composite materials. You want to create some composite material means create. So they're asking what is it, I want to give that initially if you make a composite material means you can test what are the physical properties in that lab. So that physical properties you want to keep in get ready and you can apply here. See that the temperature asking Young's modulus. Young's modulus you can check the physical properties of your material. Next, what is the Poisson ratios? If you give these three data means it's enough. The bulk modulus and shear modulus will be creating. Some other data also if you want to add means you can add much more data here. So what all the materials we available means you can create all the material, right? So I'm going to close this one. So here only we're going to give the material. Next, one more pre-processing is geometry. See that I'm going to open the geometry. Click here, open the geometry. So please listen carefully. Once you opening the geometry means see here we have one window is there. So if you open the geometry means another window will be opening. See that the another window is going to open. So we have two windows. The geometry we're going to draw separately only. See that the geometry is opening. So this is the geometry software. So listen carefully. So here we have this general window. In this window we have this product. So normally if you want to give the material means either engineer data is the question mark is there. That means the material is not assigned clearly. If not clearly assigned means we have the question mark only. So here the static structural steel is there. So see that if I click double click means the window is opening the same window only. Understand? Here the static structural is there. So you can close. You want to close here only. If you close here means automatically the full ANSYS workbench will be closed. So for engineer data, you want to close here, right? For geometry means a separate window is going to be open. Geometry means we have separate window. Once you open the window means we have three planes. That means the xy plane, zx plane, and yz plane. We have three plane. So you want to add more plane also, we have options here. See that we have create new plane. That means we have the xy plane. In the front we have the x plane. So backside I want to create one more xy plane. I want to create one more xy plane means you can create by using this new plane option. See that if I click means see that one more new plane will be creating. Which area you want to create offset to? Is it left front side or back side? Otherwise you want to create y top or bottom. Otherwise you want to create x-axis, this side or back side. Like this you can create your plane also. So this is the initially we have that plane. So this is the first window which you are opening means we are get. See in the top we have some tools we having. So if you see the first one is selection filter. That means you want to select that point, edge corner point you want to select means you can choose this option. Next you want to select the vertex. Vertex or edges means you can select this option. Next you want to select the surface of the geometry means you can select this option. Next you want to select the full geometry means you can select this option. Next we have the pan. So pan means the geometry will be moving like this. Next zoom option, particularly which area I want to zoom means you can zoom and see. Next zoom fit. If you click the zoom fit means automatically the window will be fit like this. Right. So ISO some standard set you want to make means you can made. So initially I'm going to start any diagram means see that xy plane or yz plane or yz plane means first initially I'll start with xy plane means the plane will be in isometric view. That we want to change to xy direction. The two direction only means see that we have this face. Look at face is there. Just click here. See that the x and y face will be visible. You want to zoom and see also we can see. So this is the first one. After that you're going to draw some diagrams. So how we going to draw the diagram means so this is left side. If you see means we have two option we having sketching and modeling. Now you are in modeling. If you want to go for sketching means see that in that sketching we have different types of tools we having. So the first one is a drawing toolbox. In the drawing toolbox we have line, tangent line, line by two tangents, polyline, polygon, next rectangle by 3 points, oval, circle by three tangents, arc by tangents, arc by 3 point, arc by center, ellipse, spline, construction point at intersections. Like that we have some different points we having. You can use these tools and you can make the geometry, right? Next we have that modify object. So that modify tool, if you click means see that here once you complete the diagram means that the edges we have sharp edges means you can change into sharp edges by using the fillet option or chamfering options. Next to corner points. Next you have extension line means you can trim that line or extend that line. Next we have the split option, drag option, cut, copy and paste option we have there. Move and replicate option is there. Duplicate option, offset, spline editor. So these are the modified tools which will be available. Next tools is dimension toolbar. So in the dimension toolbar we have generally general option is that. General means no need to select just click the vertical line or horizontal line. Click and drag means you can directly line. So for that line, particular line we can get. But if you have two lines, the top line is there, bottom line is there. So for this two line we're going to take means you can use the vertical options. So right side or left side we having line means for this two line we need some dimension means we can use the vertical option is there. So next one is length, distance, radius, diameter, angle, semi-automatic, edit, move and animate, display. These are the options we have there. So while explaining that exercise I'll explain all the options I can use and I'll show you. Next one more important toolbox is there, that is a constraint toolbox. The constraint toolbox is very important one. So initially you're going to draw the diagram means so this diagram bottom I'm going to fix it means you can use this fixed one. If you fix that line means automatically the object will be fixed only, you can't able to move. Next horizontal is there, vertical is there. So perpendicular is there. So if you draw two lines, I'll show you that line option. I'll show you. How do you are seeing now? So I'm going to draw one line like this, one line. I'm going to make the constraint, see the perpendicular. For this object, the line should be get perpendicular. Sorry. For this option, the okay, just a minute. I'm going to create a draw line by here. Now I have line like this. I'm going to constrain object perpendicular. This object, this should be perpendicular. See that automatically the line will be going to be changed. See that the line we have like this. I'm going to use the perpendicular option, right? See that I'm going to use the perpendicular option for this line. This line should be perpendicular. If I click means perpendicular. Again for this line should be perpendicular. It's not possible. Why? Because it's in parallel, so it's not going to be changed. So you want to make that perpendicular means you want to draw like this line or like this line or like this line or like this line means I'm going to use the constraint option. Click that perpendicular. See that for this line I'm going to make perpendicular of this line and this line. Sorry, this line and again this line. This line is perpendicular. Again this line. This line is perpendicular. It will be changing. So if you want to change somewhat parallel, you can use that tangent also for circle. If you draw means after circle, the tangent coincident next to midpoint symmetric. So symmetric means see that these two lines is there. This two lines should be symmetric for this center axis. Means see that if I use the symmetric option means for this center line and this line and this line should be symmetric. It's not possible. I'll show you. It's not possible. So how we going to draw means you want to draw like this line, right? Next, I'm going to make the modify constraint option. In the constraint option, I'm going to make a parallel. See there, I'm going to make parallel. So for this center axis, this should be parallel. Next, I'm going to use for this symmetric object. So for this center line, this line and this line should be symmetric. Wait, I'll show you again. Symmetric. This axis and this axis should be symmetric. New constraint make model over the constraint use undo. Okay, it's not possible. Estimate symmetric for this option, this line and this line. It's not possible. Okay, I'll explain next class. So, okay, while seeing the diagram, I'll explain you. So this is the concentric. Wait, I'll show you that symmetric. Wait, I'll draw some line here. See that I'm going to draw a line here and I'm going to draw a line here. Next, constraint symmetric option for this center line, this and this should be symmetric. See that automatically the symmetric will be take place. So the symmetric, how the symmetric will take place means you want to see that means from the x and y both the line should be coming like this. Then only it will be symmetric. For this two, it not take symmetric, right? So this one type of construct we can given parallel construct. Next, concentric circle. Concentric circle means see the from the drawing tool you want to make the circle. See there, here I'm going to make a one circle. Again I'm going to make one more circle means I can go for the constraint and here I'm going to use this concentric circle. Which circle? This circle to this circle. See that automatically it will be coming exactly center. So this is the circle. Next, equal radius, equal length. Example, this is the equal length I'm going to use means. So this length and this length is vary. So I'm going to click. Okay, first see the equal length. I'm going to click this length and this length. The two length will be going to be changing. See, equal length. This length should be again it's been so okay. I'll create this length. See the equal length. So already it's constrained now, so it's not changing. It not assigned correctly, so that only it's not able to change. So these are the constraints we're going to be used. Next, one more important one is settings. So in that settings, we have the grid option. See that we have the grid option. If you switch on this both grid means, so normally you are using the graph now in 10th and 12th standard, like this graph will be creating. So in this graph, you want to select the major and minor grid also. See that if you create a major grid, 5 meter is there. So if you select a 5 meter means 10 meter, and the minor grid also 5 meter. Okay, you can see zoom, and you can see that. Okay, I'll erase all the sketches. Go to the modeling, sketch, and delete all the sketches. Then only you can possible to see exactly that settings of your grid. See there. So grid. So this is the grid we having. So if you see means, see that 10 meter. That is 5 meter into 5 meter. The grid will be creating. You can possible to change the grid also. So here only you're going to draw the geometry, right? After completing the geometry, next example, I'm going to complete the geometry by using any one diagram. Next, I'm going to go for the model analysis. See that here, if I draw something, then only the geometry will be getting tick mark. Otherwise, the geometry will not getting tick marks. So you want to complete your geometry, then only you can go for your model analysis. Double click on model analysis. So again, what will happen means, we have the separate window. It's going to be open. See that. So initially they're asking the geometry is material is not setting. First you will select the material, right? So structural steel will select. See the structural steel will select. Close one. Okay. The geometry we want to complete fully. Okay, I'll show you. So here I'm going to draw switch off the setting option. Switch off these setting options. Draw initially. I'm going to draw one line. See there, simple. I'm going to draw this line body from the concept. Line from sketch. Line from sketch. Generate. Which is sketch? This sketch. Generate. Object is not selected. This sketch. Base object. Okay, just a minute. Let's close this one. So here I can go for the geometry. XY plane, look at face, sketch, line. I'm going to create a line like this. Next, from the concept, line from sketch, which line I'm going to select this sketch one line, apply, base sketch is apply. Next, create, generate. So the line is created. See the zero part is there. That line we don't have the cross section. Go to concept, select the cross section, any one rectangle cross section, generate. Okay, from that line body, change to rectangle, generate. See that now you can go the window, switch on the cross section. You can possible to see the rectangle, right? So this is the rectangle bar you can possible to see. So this is the one type of diagram which we have completed. Simple diagram I will complete it. Next to close here. Next to go for your model. Double click on model. So here only the model is there. Model analysis going to be open. So in that axis symmetry, you can create a one-dimensional object. you can create 2D surface objects, you can create 3D also by using the extrude object. You can create that line object by using that cross section from that line means it's a one-dimensional object. We can create the only the cross section alone. But you want to use the extrude option means it's a three-dimensional object. So like this, you want to draw a one-dimensional object, you can draw. Otherwise, you want to draw the two-dimensional surface object, you can possible to draw. Otherwise, you can use that three-dimensional extrude option or revolve option or something option we can use, and you can draw the 3D object also. Right now, I'm showing this the one-dimensional object, so only that line will be showing. So in this model, what we're going to have means see that we have generally three steps we are having. So the first one is in the geometry, you want to apply the material. Next, you want to create the mesh. Next one is third one is boundary condition. You want to apply the boundary condition. See that in that meshing. So meshing itself, you want to see means it's a separate class. You want to take a lot of things, right? And just to generate mesh, I'm not going to give you anything. It's a direct mesh. I'm going to create. See that directly. I'm going to create the generate mesh. Once you mesh created only, then only you can possible to see the structure of your images, right? See that. So the structure, it's a rod which can be created. Next, from the static structural, you can create. See that here we have that fixed support, displacement, remote displacement, frictional support, cylindrical support, cylindrical support, simply supported, fixed rotating, elastic. Next, you want to apply the load means we have types of load. We having pipe pressure load, force, remote force, bearing load, bolt rotation, movement, line pressure, thermal conduction, pipe temperature, joint load, fluid, solid interface. So these are the force which we have given. So these are the coming under your boundary condition. After applying the boundary condition, you can create the solution. See that the solution, you can see the deformation solution, and you can see that stress and strain condition also by using this contact tool, or you can using that probe tool, stress, strain, position, coordinate system. So all these result we can possible to find out here. Okay, in the next class we'll discuss about one experiment, then we'll start exercise. Right? Okay, thank you.